Hey YouTube, beautiful spring day. Got the old GT250 out. This is a 1974. It's been about 6 years since I've done a video on this bike, and what I did then was replace the mechanical points with a electronic ignition system. Today I'm going to put it back to mechanical points. A couple of reasons for that is when the battery voltage is low, which when you have a few bikes, you don't get to start them all the time, you don't charge them, you don't keep up with them, don't ride them. The batteries are always low, so this one never starts. I have to go and charge the battery for a little while when I want to take it down the street or something. The other biggest issue I've had with this is the RPM range. This bike redlines at about 8,000 RPMs, and I think there's an internal RPM limiter in the computer here, the control module, that limits it to about 7,500. So on a bike like this, that's about 10 miles per hour in top gear. That's the difference between city driving and freeway driving, which could be a little hairy anyway. But I think it's a good time to get started, get this thing back on the road. This 250 I have a particular fondness for. It was given to me back when I was in A&P school for aircraft maintenance. One of the students that was there with me said he had an old 250 Suzuki in his barn that was about to fall in, and I could have it. So I didn't know anything about two-stroke street bikes. He said it was a two-stroke. I assumed dirt bike. So I went to his house. Long story short, barn was caving in. These dream stories that you read, and this is my experience with this. I saw the front end of this bike back in the corner, and to me it looks like a British bike from the front, especially covered in an inch of dust. And I was thinking, wow, what a neat bike is that? I wonder if he'll sell that one to me, and where's the Suzuki? And he walked right over to that and said, here you go, and I couldn't believe it. So this was my introduction to the two-stroke street bikes, and since then I've had two-stroke twins, triples. I've got a GT750, the water-cooled version of this. Kawasaki S3, the early Widowmaker, if you will. It's a 400cc triple. I've had a series of RDs, and the reason I've kept this one so long, it's been across the country with me a couple times, is because until recently these bikes were not very desirable. 250s kind of laughed upon, and like me, uneducated, I hear 250 Suzuki and I instantly blow it off. Not so much anymore now, but these bikes are very capable. I would compare this more to like a 400 four-stroke, like a CB 360J. That kind of, it handles about the same as that too. But what Suzuki did with this one, that it doesn't have a reputation for being awesome, because the RD family, and I've owned those, they really do make a big difference. They've got reed cage inductions, and that does really make the bike seat of your pants, really grabs you, and you get off the bike shaking on even the 300s, and I've had a couple of RD 200s, electric start bikes. But I think that Suzuki, when they built this bike, is towards the end of the two-stroke reign. I think they built this for people that didn't like two-strokes. They made the power band real mellow and wide, so a beginner could get on it, keep up with traffic. And I'm comfortable at a traffic light on this one, where I wasn't on the RDs or the Kawasaki's, Suzuki's, and other bikes that are two-stroke. You have to keep them blown out, and with traffic and stuff, there's never enough space on the older bikes. This one, what I was going to say also is the reason I've had it so long is because the values of these have never been high. I've never wanted to sell it, and I'm glad for that now, because like I said earlier, I got this one for free. But I see these for sale here locally. I'm in Nashville, Tennessee. They're like $1,500. I don't know if people are actually getting that or not, but that seems absurd to me when you go from free to $1,500 in like 5 years. But anyway, that's where I'm at, and I like the bike. That's the biggest reason for working on it. Now that I've got the stator cover removed, I want to show you what I had installed. Originally this would have been a cam, and this has been replaced by a plate with cutouts on it. These cutouts pass these two photo eyes, left and right cylinder. They work kind of like a garage door opener. If you ever shut a door and then have your dog run outside, or you go under it and the door opens back up, that's essentially what's happening. You're breaking a beam with this plate, and that information is sent digitally to this ECM box. This is a sealed system. I installed this 6 years ago to have a more reliable ignition system, something you don't have to adjust, parts that don't wear out. Well, guess what? 6 years later, this is not working, and I can't really troubleshoot it. There's nothing to do. So here we go, back to something mechanical. Something else I want to mention with this bike is it does not have a voltage regulator. I remember years ago, you have to put the right battery in these. the battery acts as part of a part of a kind of resistor. So for instance, if you have one light blow out, like your headlight blow out, you'll notice that your turn signals go out and your brake light goes out. Every time you lose a bulb, the voltage goes a little higher. I was testing this originally with an oscilloscope to see if I was getting any AC current bleeding through the rectifier, and then I realized that it was fine, all DC, but the voltage was 22 volts DC, and you could put the correct battery in here, which is a USA makes a good battery, USA OEM standard battery, and that brought the voltage down to 16 volts. So for a 12 volt system, 16 volts is plenty. Moving right along. So I've got the old components installed, and the first thing I want to do is make sure that these open to the proper gap. So on these old bikes, especially the Kawasaki's, I've noticed that the markings are not that accurate. I like to have a baseline and eliminate as many variables as possible so it goes smooth either this time or the next time or when you're troubleshooting. So I've got a dial indicator set up here, and 0 is the highest point on this lobe, which I will turn and just prove. Some bikes have a mark on this cam to show you the highest point, and the purpose of doing this is to know that your points have opened that follow this cam as wide as they're going to open. So I'm going to turn it till it gets to the highest point, which is right there. And I've got a center punch, and I'm going to put a little dot right there. So now I can see this and rotate the engine over to the arm on the points, and when it's parallel to that, I know that this gap is as big as it's going to get. Looking up the specs for this engine, the point gap should be 12 thousandths to 16 thousandths. So I'm going to set it to 14 thousandths, right in the middle. Got my feeler gauge set here. 14 thousandths. Make sure there's not another one behind it like that. And that dot we made earlier is lined up with the phenolic finger that's on the points. So I know that this gap is as large as it's going to get. I insert my feeler gauge, try to keep it parallel, loosen the screw, and then adjust until there's just a slight drag on there. Make sure that it's straight, but you can kind of hear it crunching a little bit, but not pulling the gauge away. So tighten that back down, and then now I'm going to take the largest gap, which is 16 thousandths, and make sure that it does not go in. I would have to push it at this point. Okay, then I'll take the smallest, which is 12 thousandths. Bear with me. And make sure that it goes in freely. So I know that I am within the range of 12 to 16 thousandths. We'll do the same thing for the other cylinder. The first method I'll show you for timing is the traditional way that most manuals tell you how to do, with either a timing light or, in my case, a buzz box. And another method would be using a simple multimeter and using diode or continuity check that has a beep. What's going to happen is you'll have continuity until these points begin to open, and the pitch will change on my buzz box, or your light will go out, or your multimeter will stop beeping. So we're looking through the window to line up an L or an R, depending on which cylinder you're timing, and that it lines up with the hash mark at the right time. This box makes a terrible racket. I apologize in advance. I dug it out of the garbage a long time ago. It's probably from the 60s, but here we go. So now I'll be turning the crankshaft in the direction that the engine runs and looking through the window. There's the mark, and there's the noise change. So I'm going to go back and forth, and you can see that the pitch is changing when the mark passes, so that tells me that the points are beginning to open at the right time. Earlier I described a way to tell when the points are opened by a test light. It's just one of those little pokey probe test lights you can get at an auto parts store. Put that on the positive of the battery. I've clamped the other end to the pigtail on the points, so when the points are closed, this light will come on. And when the light goes out, you know your points have just opened. Pretty good way of doing it if you don't have the buzz box, but it's still, you have to move your eyes from, if you're looking at some little mark, you have to move over here. It's better to have the sound, I think. So a multimeter or that buzz box would be preferable. So what I'm doing now, to set this dial indicator up, I'm going to take a wooden dowel, place it into cylinder number 1, into the spark plug hole, and turn it over until the piston is raised as high as it's going to go. So I literally am just feeling it. And that's it right there. So I've installed the dial. It doesn't really matter which direction you put it. This I printed off the internet and attached to a piece of aluminum. These are free. It has all the degrees, 0. Need to kind of know where that is. So I've put the engine at top dead center with my dowel. I'm going to put my homemade pointer on the end of the crankshaft and carefully put it at 0. So every time that comes around, that piston's at top dead center. Now I'm going to use the Kickstarter to turn the engine in the proper direction. You can see we're going up towards 0 again. It's currently closed. Real carefully, I'm going to start bumping it a little bit, watching the light with my right eye. Bump, 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 bump. Almost there. That went off at 15 degrees before top dead center. That gives you an idea in degrees when your points are opening. This is a good method for port timing. You can tell in degrees when your ports are becoming covered and uncovered exhaust intakes that. And in a 4-stroke world, your valve overlap and things that you just can't measure any other way. This is the fastest way. I don't like this method for timing because everything's so tedious. A wire's got to be there. If you've got to make an adjustment, how are you going to get to your points there? So this is my second favorite method, and everything's visual, but it's a good explanation right now. It's just a little too Ichiban Moto for me. The zip ties did come from Nickeltown Customs. If you guys are looking for these high-speed green ones, you've got to go to his channel and check out some of his videos. They're really good stuff. This is my third method to explain, and it's my favorite. Use a dial indicator that actually rides right on top of the piston, so you know exactly where top dead center is. In terms of 2-stroke, this being a piston port timing, I think that's the most important thing, the correlation between the piston position and the bore. So when you know where top dead center is, by zeroing it on the indicator, and this engine runs counterclockwise, so I'll start by zeroing it, turning it counterclockwise. The evil, wicked, mean, and nasty buzz box is back. I've got it covered up, but it's still going to be, sorry for the noise. I'll shut it off as soon as I can. Turning the engine back, counting the increments. I've got it. It's really tripping at 18, but that's backwards, so we got to subtract 18 from 100. Yeah. So I'm going to say 82 thousandths. Yeah. 82 thousandths. Let's check it one more time. Go around. And do it again. Thousandths. I'm going to say 88 thousandths of an inch before top dead center is when these points are opening. We're going to have to make an adjustment, because according to the chart, it should be opening at 2.93 millimeters, which converts to 115 thousandths. We're getting 88 thousandths. So that goes to show that when you go, and you saw earlier, I set this up by the mark, on the mark. So that mark is off almost 30 thousandths. I don't know. Tell me what you think in the comments, see if that really does make a difference. But I know we're doing all this statically, and I really feel like dial indicator is the way to go. Someone out there is not going to agree with me, but that's fine. Let's discuss it. Thanks for watching.